Hi Shivani, after a long time. I'm fine, good. Hello, hi everyone. Welcome to the Student the Brand. This is your Shiva sir. Today topic is electric current. So in the previous video you can observe. So I explained about electric current, electric current definition. So the rate of flow of charge, SI unit of electric current is ampere, SI unit of charge is coulomb, SI unit of time is second. Okay, so that is about electric current. And next topic is like quantization of charge. After that, electrical appliances, electrical circuit. After that, we discussed about conventional current and electric current. After that, we discussed about potential difference and electrical potential, potential difference and electrical potential. After that, we discussed about Ohm's law. Ohm's law. After completion of Ohm's law, so resistance factor depends on resistance. So resistance directly depends on length of the conductor. Resistance is inversely proportional to resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to L by A. So R equal to rho into L by A. R is the resistance, rho is the resistivity. R is the resistance and rho is the resistivity. Okay, so about these topics we discussed. So about these points we discussed about electric current, completed. Now we are going to discuss about uh, continuation of electric current, continuation of previous live class. That is, resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination, resistors are connected in parallel combination. So right, chalo, then we'll do it. So resistors are connected in series combination. So normally if you are considering here, okay, resistors are connected. So today we'll do problems also. So actually we are missing the problem. So we are not able to do the problem. So that is the reason today we are going to discuss about la electricity problems. Definitely will work out. Okay, so I'll give few problems. We'll do it. Okay, so be ready for that. Now I'm considering here resistors are connected in series combination. Resistors resistors are resistors are connected in series combination. Resistors are connected in series combination. Okay, so now I'm considering here. So if resistors are connected in such a way that all resistance are connected in such a way that, okay, so I'm taking this the one resistor, this is one resistor and one more. So three resistors I'm connecting. So three resistors I'm connecting. Okay, so I'm taking here 1 and 2, 3. So there are three resistors. So ammeter I'm connecting here. Ammeter. So switch I'm taking here. Switch. Okay. So now I'm considering here. Okay. Here current is flowing. Positive terminal, negative terminal. Current is flowing. Current is flowing. Yes or no? Current is flowing. Current is flowing. So current is passing through it. Current is passing through it. So if the current is passing through the circuit, if the current is passing through the circuit, throughout the circuit current is same. 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 I'm taking here. So this is R1, R1, R2 and R3. Okay, so three resistors are connected in series combination. Three resistors are connected in series combination. R1, R2, R3. R1, R2, R3. Three resistors are connected in a series combination. Okay, across R1, across R1. So current I is flowing. Current I is flowing. Current I is flowing. Across R1, I am taking V1. Across R2, I am taking V2. Across R2, I am taking V2. Across R3, I am taking V3. Across R3, I am taking V3. So current is flowing. So positive terminal, negative terminal, positive, negative, positive, negative. So throughout the circuit, current is same. Throughout the circuit, current is same. Throughout the circuit, current is same. So that's why I'm taking. That's why I'm considering here. So IS equal to current in series combination equal to current through I1, current through R1, current through I. So R1 through R1, I1 through R2, I2 through R3, I3. That is equal to I only. So because current is same, current is same, current is same throughout the circuit. So from the entire circuit, current is same. Current is same. So current is same. Okay, current is same. That's why I'm taking R1, R2, R3. So across R1, V1, across R2, V2, across R3, V3. So that's why IS equal to I1 equal to I2 equal to I3 equal to I. Okay. So now we are considering here. Now I'm considering here. Okay, so potential difference is different. Potential difference is different. So potential difference in series combination, potential difference in series combination, potential difference in series combination. Vs equal to V1, V1 equal V1 plus V2 plus V3. So potential difference in series combination is equal to potential difference in series combination is equal to V1 plus V2 plus V3. V1 plus V2 plus V3. V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. Then IRS equal to if you are taking IRS equal to IR1 plus IR2 plus IR3. So I am taking IRS equal to IR1 plus IR2 plus IR3. So I am taking I common. If I am taking I common, so I we can take common. So if I am taking I common, then so if you are taking common R1 plus R2 plus R3. So if you are taking I and I get cancelled, I get cancelled. So I am taking I get cancelled. If you are cancelling I value, the remaining values are RS equal to so I am taking RS equal to R1 plus R2 plus R3. R1 plus R2 plus R3. So you have to add all the resistance. So if you want to find out the resistance in series combination, you must add all the resistance. RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. So this is about resistance in series combination. Resistance in series combination. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, then RS equal to NR. If n number of resistors are connected in series combination, if n number of resistors are connected in series combination, so if you are taking if n number of resistors are connected in if n number of resistors are connected in series combination, so RS equal to NR. RS equal to NR. Rs equal to nr. Okay, so is it clear? So next one, resistors are connected in parallel combination. Resistors are connected in parallel combination. So based on that one, we'll do problems also. Few problems. So parallel combination. Parallel combination. Parallel combination. So I'm taking here so here is resistors are connected in parallel combination. If resistors are connected in parallel combination, you can see here. If resistors are connected in parallel combination, resistors are connected in parallel combination across R1, R2, R3. So potential difference is same. That's why Vp equal to V1 equal to V2 equal to V3 is that is equal to V. So this condition is very very important. So make sure that this condition is very very important, very important condition, very important condition, because so this they will give for 1 mark. And one more you are considering, current is different in in the parallel combination. So in the parallel combination, current is different. So through each appliance, current will be moving in different way. So according to the requirement. Now you are considering here. I'm taking current in parallel combination. Current in parallel combination. IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. Why current is different in parallel combination? Current is different in parallel combination, but potential difference is same. Potential difference is same. Potential difference is same. Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same. Potential difference is same. Current is different. Current is different. That's why I'm considering from Ohm's law. Ohm's law, V equal to IR. V equal to IR. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is equal to, that is Ohm's law. That is Ohm's law. V equal to IR. V equal to IR. V equal to IR. So from that, V by I equal to V by RP. I equal to V by R, because potential difference is same. That's why I'm taking V by RP equal to V by R1 plus V by R2 plus V by R3. So in this, as I said, potential difference is same. Potential difference is same in parallel combination. Potential difference is same in parallel combination. So we can take V common. So I'm taking V common. Okay, so I'm considering V common. So now I am taking V by RP equal to V common 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R3. So we will get cancelled. 1 by RP equal to 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by RP equal to, so here 1 by RP equal to 1 by R1 plus 1 by R2. So plus 1 by R3. If resistors are connected in parallel combination, if resistors are connected in parallel combination, if resistors are connected in parallel combination, so potential difference is same across R1, R2, R3. So current is different across R1, I1, across R2, I2, across R3, I3. So that's why IB equal to I1 plus I2 plus I3. V by RP equal to V by R1 plus V by R2 plus V by R3. So I'm taking V common, V will get cancelled. I'm taking V common, V will get cancelled. The remaining value is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected in, if n number of resistors are connected in, if n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, so 1 by Rp equal to 1 by Rp equal to n by R. Rp equal to R by M. This is about resistors are connected in parallel combination. Resistors are connected in parallel combination. I hope you got it. Next one we are going to the next topic, that is heating effect of electric current. Heating effect of electric current. So heating effect of electric current. Heating effect of electric current. Heating effect of electric current. Now you can see here, heat produced in the conductor. Potential difference is equal to work done by charge. W equal to VQ. So we know VQ, W equal to VQ I am considering. W equal to VQ. W equal to VQ. So that is nothing but W equal to V into Q. So we know that. So power equal to rate of doing work. So VQ by T, that is nothing but V into Q by T is nothing but I. Q by T is nothing but I. So I'm taking I. P equal to VI. P equal to VI. So energy is given to the conductor is equal to P into T. So we know P equal to VI. VI into T. VI into T. VI into T. So VI into T. That is nothing but IR into I into T. So we can take heat produced in the conductor is equal to I square RT. I square RT. I square RT. So heat produced in the conductor is equal to, so H is directly proportional to square of current. H is directly proportional to resistance. H is directly proportional to time. Heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. So this is about heating effect of electric current. Heating effect of electric current. Okay. So this is also known as Joule's law of heating. This is also known as Joule's law of heating. This is also known as Joule's law of heating. Joule's law of heating. Yes or no? So heating effect of electric current. Next one, short circuit. The direct contact of live wire and neutral wire takes place. Then a heavy amount of current will be drawn from the mains. The direct contact of live wire and neutral wire takes place. Heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. So it leads to the fire in the building. Okay. So and one more thing we can see. Overloading, high voltage appliances on at a time. High voltage appliances on at a time. Heavy amount of current will be drawn from the mains. High voltage appliances on at a time. Heavy amount of current will be drawn from the mains. Okay. So then it may leads to the short circuit. It may leads to the short circuit. Okay. So that is about overloading. That is about overloading, right? Next one. So we will discuss about one more. That is fuse, electrical fuse. Electrical fuse is nothing but so fuse is a safety device. So which safeguard the appliances more than its required limit it goes. If the current is flowing inside of the circuit more than its required limit, more than its necessary limit, then it melt and breaks the circuit. It melt and breaks the circuit. That is called fuse, electrical fuse. And coming to the earthing, so it is if any extra current is there, if any extra current is there, so in the circuit that will send to the ground, okay. So if any extra current is there, that will send to the ground. That is the use of fuse, earthing and fuse. These two are safety devices. Earthing and fuse, these are the safety devices we are using in household. Okay, so that's enough. Next we are going to one more. That is, so this question is very, very important. So I'm going to write one question. That question they will give for 3 marks. I'm going to write one question. That question they will give for 3 marks. So make sure that you are practicing this question. Say 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. Can anyone solve this question? Can anyone try this question? So 750. So I'll explain this question. It's 750. Sanya, thank you, Sanya. Thank you so much, Sanya. So here, a 6 ohm resistance. So here you can see a 6 ohm resistance wire is doubled on itself. So normally I am taking this the wire 6 ohm resistance AB wire. Okay, doubled on itself, it is folded. So best example, you are taking this wire. Okay, so this the wire. So this the wire. Okay, so I'm taking this the wire. So this the wire I'm taking, right? So this I'm considering. If it is doubled on itself means, if it is doubled on itself means, simply I'm folding it. Okay, so if you're taking this the wire, if I'm taking this the wire, so you can able to see this. Now you can observe. Okay, so I'm taking this the wire. I'm taking this the wire. So if it is doubled on itself, you can see a 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. So we have to calculate the new resistance of the wire. So I'm taking this wire and folded on it like this. Okay, doubled on itself. Double on itself. So now you can observe in the previous case like this. So here normally if you are taking this area of the cross section and length, when you are folding like this, when you are folding like this, length become of area of the cross section is doubled. Length become of area of the cross section is doubled. Yes or no? Length become of area of the cross section is doubled. Same thing I'm taking here. So here I'm taking like this half of the length. So I'm taking the half of the length. Length is, so here I'm taking length become half. So I'm taking here, so L by 2 and area of the cross section is 2a. Area of the cross section is 2a. So length is becoming of area of the cross section is doubled. Yes or no? Now you can take, so we know the formula, we know normal resistance given data that is 6 ohm. Given data R equal to 6 ohm. Initial resistance is 6. Now R equal to rho into L by A, that is 6. R2 equal to rho into L dash by A dash. Anyway, so material is same. Resistivity does not change. So now L dash equal to L by 2 and A dash equal to 2A. L dash equal to L by 2. L dash equal to L by 2, A dash equal to 2A. Now substitute in this formula. Now you can substitute in this formula. RT equal to, or R dash also we can consider. So instead of you are taking R2, you can consider R dash. So instead of you are taking R2, better you can consider R dash. R dash if you are taking, this is rho into L dash is nothing but L by 2. So A dash is nothing but 2A. Then you will get a rho into L by 4A. So then you will get 1 by 4 into, so rho into L by A is R. So R dash equal to 1 by 4 into this is R. So R dash equal to R by 4. So R is already we know. R equal to how much? 6 ohm. So substitute 6 by 4, that is 3 by 2. That is, what is the value? 3 by 2 is how much? 3 by 2 is 1.5. 3 by 2 is value how much? R dash equal to 1.5 ohm. So that is a, so new resistance of the wire. Understood? So this is 1.5 ohm. Once again I will explain. Listen carefully. Very, very important. 3 marks question. Again I am saying very, very important. 3 marks question. Very, very important. 3 marks question. Okay. So that is, you can observe here. So a 6 ohm resistance wire is doubled on itself. A 6 ohm resistance wire is doubled on itself. Calculate the new resistance of the wire. Suppose I am taking this, suppose I am considering here. So this is the length of the wire. So if it is doubled on itself, so I'm taking like this, I'm folding like this. Okay. So length become half. Area of the cross section is doubled. So here length L by 2, area of the cross section is 2A. So substitute R equal to rho into L by A. So 6 ohm, R dash equal to rho into L dash by A dash. So length become half, area of the cross section become doubled. Okay, so then we can take here R dash equal to rho into L by, material is same. R dash, so that's why R dash and so everything is same. Okay, initial or final both are same. That's why you no need to change that resistivity. Material, it is depends on material, right? So it is depending on material is not changing, so material is same. That's why I'm taking here. So R dash equal to rho into L dash by A dash. So L dash equal to L by 2, A dash equal to 2A, L dash equal to L by 2, A dash equal to 2A. So I'm taking L by 2 into 2A, that is rho L by A, that is 1 by 4 equal to 1 by 4 equal to, so rho into L by A, that is R dash equal to 1 by 4 into R dash equal to R by 4. What is R value? 6. What is R value? 6. R value is 6. R value is 6. So 6 by 4 is, then we'll get 3 by 2, that is nothing but 1.5. 1.5. Yes or no? So this is about this is about okay. So very important, very important. So definitely 3 marks question. So this question will come for 3 marks. Make sure that you are preparing this one, right? Okay, so take time and note down if you want. Otherwise, I'll go to the next question. So one more question, So try to work out on this one. So that is resistance of the wire, resistance of metal wire of length 2 meter. resistivity is equal to what will be the resistivity of the metal at that temperature. Okay, instead of explanation, better you can go for homework. So I'm giving homework, this question. Try to do it and do comment in the comment section. Thank you so much. Homework. 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 Dun, 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 dun. Okay, so we'll see in the next class with few more problems. So this is our Siva sir signing off. Thank you from Student the Brand.